Let's see how we can understand assenting or agreeing with, assenting to a proposition. And I'm using John Henry Newman's Grammar of Assent as a beginning here. So he asks, and we ask, when can we assent to, that is, agree with, a proposition? Well, we should apply principles of logic here. But why should we do that? Example. An object in motion stays in motion with the same speed and in the same direction unless acted upon by an unbalanced force. That's Isaac Newton. The philosophical question is why? Why use principles of logic in looking at statements like Newton's first law? Well, when we ask this, we're asserting that the world has an order, and we can discover that order through logical inquiry. Now, if you want to say that, you have three and only three options. The first option is denial. So we're going to look at all three possible options. You can deny that the world has order, and you can decide that the world has no logic or design, and therefore all science is an illusion. You can turn off this video and just forget about studying science or mathematics. That's one option. Scientists, as you can imagine, don't take this option. The second option is design by intelligence. You can agree that the world has order, and you can attribute that order to an intelligence that has the power to create that order. You can call that God or something else. That's option 2. Option 3, I leave that for family discussion. You can agree that the world, yeah, it has order, and I'd like to study it. And you need to talk to your parents or other mentors about how that order might have come about. I'm not going to tell you the answer, because that's beyond my portfolio as a science teacher. So, moving forward, we're going to assume that you agree there is order, and that order can be discovered in the world, in the universe, and we can then begin to study the action of assent. So, there are several ways to state a proposition or hypothesis. As an interrogative, for example, does free trade benefit the poor in society? You can also think of it and state it as a conditional or an if-then statement. That is, if trade between states is free, then the poor have a better life. Or you can state it as a categorical assertion without any conditions. Free trade benefits the poor without exception. Now, getting out of economics, we can look at this in physical and biological science and see that the three often follow each other. When we ask, for instance, does a measured amount of metal X always react with the same amount of oxygen gas and form the same amount of oxide? That's a question. We could state before the experiment, if 4 samples of 150 milligram magnesium react with oxygen, 250 milligrams of oxide are formed. Or you can say, reacting equal amounts of magnesium with oxygen always produces the same amount of oxide. So those are the three ways we can state that proposition or hypothesis. And this is some magnesium. Now, how can we hold propositions in mind? Well, we can do so with doubt. We can say, I wonder if I react magnesium with oxygen using identical amounts of metal 4 or 5 times, if the same amount of oxide is always produced. Or with inference. I have reacted 150 milligrams of magnesium 10 times with oxygen, and each time I did, 250 milligrams of the oxide is produced within the margin of error of the investigation. Or by a clear assertion. Unquestionably, reacting equal amounts of magnesium with oxygen always produces the same mass of magnesium oxide, and you might even add within the margin of error. You are probably aware that the progression of these three how can we hold, the three ways of holding a proposition, outlines the experimental method of most biological and physical sciences. In other words, we start off with doubt and we end up with assertion. Now, what's the role of evidence in our investigations? Well, in Texas, the TEKS, for every science, they require that students be able to do this. In all fields of science, analyze, evaluate, and critique scientific explanations by using empirical evidence, logical reasoning, and experimental and observational testing, including examining all sides of scientific evidence of those scientific explanations, so as to encourage critical thinking by the student. Now you see that the order of the physical universe and our ability to observe regularities and make deductions of physical laws, that is implied right here, that we are studying something that is ordered. Are we limited then in our ability to assent to statements about reality? Do we always need to observe physical systems and measure changes in those systems before we can confidently assent to any proposition? Well, let's look at one limit to our assent to statements. A relative takes a well-advertised food supplement and it's supposed to improve memory. I ask, do you believe that this supplement improves your memory? She answers, yes, and I have to believe that because it's pretty expensive. Now, how does she know that her memory is better than it would have been without taking the material? Answer, she doesn't. There's only one of her. She can't do any kind of experimental investigation. There's no way to determine what her memory would be like without the supplement. And of course, you would have to actually test her memory with and without it in order to come to any kind of conclusion. Well, how does she know, or what evidence does she have that her memory is better than it would have been without taking the material? Well, this is the reason why scientists will insist on controlled experiments in which only one variable is controlled at a time. And with animal or human experiments like this, we use double-blind experimental design so that nobody involved knows whether the pill has the supplement or a placebo. And multiple runs, of course, by multiple investigators is always recommended. That's why it seems like getting a new vaccine on the market, for instance, is so slow, and it ought to be. You ought to know that it's safe and effective, and you can't just test it with a few people or a few investigators. You have to do it a lot. And suppose we do all that, and we find, measured by standard memory tests, those taking the supplement had a 20% improvement above the control group after 90 days of use. Does that mean the supplement caused the improved memory performance? If you understand logic, you know that this is the post hoc propter hoc argument. Is there another factor that might have caused the improvement? And does that mean in every human population we should expect the same result? And should my relative continue the significant outlay of cash needed to continue this treatment? The answer is not necessarily. Further testing will yield more evidence. Thus, our assent to these statements must be conditional. Note, this is real assent, but it's conditional. How do we get evidence for simple questions like we find in mathematics and geometry? We're getting outside in that case, the nutritional science. So we see a proposition. Corresponding sides of similar triangles have proportional lengths. There's an example of two similar triangles. There's two ways to proceed. First, you do a geometric proof. You start with a definition, and step by step, you logically assent to or dissent from the proposition. So, we first start with the triangles are similar. Then we have a series of logical statements. I remember dropping a whole bunch of perpendiculars when I did geometrical proofs. And we determine that AB over DE is equal to BC over EF. What kind of assent does this evidence produce? Well, it's intellectually satisfying to many people, but most of the time it doesn't grab people's attention because it doesn't look like something related to the real world. This kind of evidence gives a result that is mathematically perfect and has no uncertainty to it. And this produces what Newman calls notional assent. The notion makes perfect sense. It's logical. There's a second way to proceed to find out if corresponding sides have proportional lengths. Empirical proof measures dozens and dozens of similar triangles and tests to see that corresponding sides are proportional. So you measure. You draw a bunch of triangles, make sure they're similar, and then you measure. You spreadsheet the data, and you confirm that within experimental uncertainty, when you divide these two sides against those two sides, you get about the same ratio. What kind of assent does this kind of evidence produce? Well, it's very engaging because it makes you get out your tape measure. It gets you directly involved in the measurement and does look like something related to the real world, like an engineer would do. But this kind of evidence has built-in uncertainty, and to be compelling, it must be repeated many times by many people, and it's only valid within the data available. This produces what Newman calls real assent. The proposition does make sense, but it can't be called a universal truth like we could with the logical, from definition, step-by-step proof that we did before. So I'll ask you, what is more valuable in science, real or notional assent? That's something that you should think about, maybe write your thoughts down, and talk about to your teacher or with other students.